And let's pin that thing. All right.
This is what happens when you get a Geek dance party.
Yeah.
Welcome to the ACM webcast. Thank you for joining us today. For anyone who wasn't aware of the changes, this was originally going to be a webcast with Chris. However, he could not be here today, so instead, you guys have the privilege of having John here instead.
And we'd all like to just say sorry.
And John, who are you again, John?
What's that?
And who are you again?
That's okay. You'll know me.
Have you ever considered getting like a biological implant where there's always a webcam right at your face and you got a microphone coming out of your shoulder? So that you can just...
or closer is just Jason. He puts the entire thing in his kitchen. That's commitment. That's
Wow.
Yeah, we haven't had a family dinner in quite some time.
We should rename the webcast to John Strand and Friends.
Daddy, can
Fun with
VHIS
C2.
get us a new house? Do we have room for all this?
Yeah.
No, Susie. I'm sorry.
Before we get started, John, what T-shirt are you wearing? What's that shirt?
I am wearing the BHIS Joy Division.
Okay, now I'm wearing the.
What I hate about it though is whenever I sit down, the information security gets wrapped in the rolls of fat, so I have to do that. So
Yeah. Yep.
And it's that negative discharge leaks thing. There's no
I just
ink
like
on it.
touching it, and it makes. And when I do it, it's creepy. When someone else does it, it's assault. So no, it's a very comfortable shirt actually.
Yeah. And I'm going to do one shameless plug for the new store. I'm going to throw it into the Discord channel. We have a new store. All of the proceeds, net proceeds of selling our t-shirts, and we will have active countermeasures t-shirts in 2021, but all the net proceeds goes to the Innocent Lives Foundation.
Which is an amazing group of people.
Where did the epic cat astronaut portrait get made or come from? Keith?
Well, actually, I can't even remember. It was some random store. We were on vacation in Tennessee somewhere, and I saw it hanging on the wall, and I had to have it. So there you go. And just so you know, his name is Major Tom.
Of
Perfect
course
name.
it is.
I love it. I love it.
That is awesome.
That cat's thinking to itself, "You're not going to stick me in another damn costume, are you?" Oh, yes.
Yeah,
Isn't
well,
there like a whole cat and costumes calendar that you can buy?
Oh yeah,
Sure could. Oh, yeah.
tons of
Yep.
them.
Hey, Joff, why are you here?
I don't know. Why am I here? No, I'm here because John sent me an email this morning saying, "Hey, Joff, why'd you show up?" I'm like, all right.
I kind of need you to come fill some space. Can you do that? Joff's like, boy, do I got you.
Yeah, I've been busy writing my class, so I've got a few slides that might be applicable to C2. So
Joff's even surprised. We're going to play slide roulette with Joff's own class to see how well he's actually prepared for his own course.
welcome to Fun with C2 with John and Friends.
Jeff, did you want to talk about what the upcoming class is a little bit, and I'll post a link for people who want
Do we
to
have to
check
do
it
that?
out.
Why not? Wow, I could do this like semi-efficiently. I am teaching a class, developing the class that's going to be taught in January anyway, called Enterprise Attacker Emulation and C2 Implant Development. I can't do that without taking a breath in the middle of the sentence.
That means we got to come up with a better name.
A lot of syllables.
It's a long title, but I blame John Strand because I said, "Hey, John, what should I call that?" He goes, "How about this?" I'm like, "Okay, sold."
Wow. Right in front of everybody.
Yeah, there it is.
But, I felt the bus.
Yeah.
Yeah.
It's all good. I don't know whether we'll come up with another name or not. But anyway, we're going to talk a lot about C2 in the class. We're going to talk about advanced malware development and different ways to model, attacker emulations and threat actor and C2 behavior, anatomies of C2 channels. Boy, I wasn't prepared for this at all. I'm going to introduce my own framework, which I'm going to make available to the class, which is going to be used as a teaching tool around C2. And we are going to be covering different languages in terms of how we might be able to do things like shellcode delivery and establish C2 channels in C# and Golang and Python. So we're going to have a lot of fun. We're doing 4 days, 4 hours a day. The registration link is available already. And Shelby, hopefully you're posting that in the Discord.
Yes,
and,
I am.
If you're interested, I think it's going to be a lot of fun. One question that does come up and has come up already with some early interest has been, will this be able to evade endpoint defenses? And the answer is yes, probably, but the journey is always challenging because endpoint defenses are always changing. So you will see how that plays out as we do the class. So there you go.
Very good.
Really, that's about it. We got a great section lined up of slides and labs, and we'll have a Windows VM that people will use. And John has had the privilege of reviewing a few of the slides, and I think he's excited about it. And some others will be doing the same. We're going to kick it off in January. So really cool.
And the coolest thing about it is you have a lot of people that, they're working just standard security, and the standard security tools and the implants don't work. So it's basically allowing a security professional to go from someone who is not able to create their own implants to the point where they can create fully functional implants. And one of the things you're going to find out is just by creating your own implant, many times standard antivirus engines start just missing everything that's going on. So that's a good way that organizations can start doing that type of threat emulation in their own organization, like the real attackers do as well.
And I promise you won't need to have a lot of programming knowledge. I am going to give you a whole lot of code that goes along with the class so that you can use it, reuse it, and do whatever you wish with it. Just don't hold me accountable for it.
so much copying and pasting. And it's funny because I could see people showing up to this class and being like, yeah, we're doing a lot of copying and pasting in this class, but is that really what real coding is like?
And the answer is yes.
It's exactly like that. So much copying.
There's an Oh Really book on copying pasting from Stack Overflow for fun and profit. And I would be embarrassed if I had to admit how much of my programming work came down to that.
Okay, I've got a question for you, Bill. Have you ever looked up code, found what you're looking for, started copying it, and then realized it was the code that you wrote?
At least 5 times. I have done that so many times. My own blogs show up on the first page of results. It's like, oh yeah, that's right.
That's happened to me in recent history while pen testing. I'm like, man, how do you do this? How do you do it? Wait, this is Guy Choff. He did it before and wrote about it. What?
Yeah.
Yes.
The younger version of me was so much smarter.
Oh yeah.
So I think I'm going to ask the people of Discord, bring us your favorite Chuck Norris jokes. Let's have it.
Discord
What
light
are
up
your
now.
favorite Chuck Norris jokes? And in the last 2 to 3 minutes, I'm going to tell a Chuck Norris story to get these juices flowing. So on the set of Walker, Texas Ranger, years ago when that was still a thing, they actually had a baby lamb that actually wandered into the scene while Chuck Norris was doing it. And that was fine because they're in Texas, you're going to have baby lambs all the time. Unfortunately for everybody that was on the set, the baby lamb just died right there in the middle of the set of Walker, Texas Ranger. And Chuck Norris went up to this baby lamb and nuzzled the baby lamb with his beard. And the baby lamb came back to life on set. They actually got this all on video. But then Chuck Norris did a roundhouse kick and killed the baby lamb just to prove that Chuck Norris giveth and Chuck Norris taketh away.
Right.
Is that on video too?
E.Q. Norris at his best.
Oh, there we go. So that you told me to tell the best joke I have. That's it. It's not a good joke, but that's it.
Yeah, I'm not sure if I'd consider that a joke, more just a disturbing story.
There you go.
There are many of those.
All right, everybody. Well, thank you so much for coming to this webcast. If you're looking at me and you're saying to yourself, hey, that's not Chris Brenton, you're very observant. I'm not Chris Brenton. A bit of a family emergency. I had to set in for him on this particular session. And I do apologize to each and every one of you, but Chris will be back at earliest convenience. So this is a kind of a neat presentation. If you're interested, the slides are in PDF form in the Discord channel. And if you look in the chat and go to webinar, you're going to find a link to the Discord channel, and they're pinned at the top. So you can get those and you can share them out. So this is actually a big deal. It is for a number of reasons. The first reason why it's a big deal is because we're finally getting to the point where we have an organization that is developing a series of standards around network threat hunting. And I know for a lot of you, you like the idea of Rita, you like the idea of what we're doing and how we actually go about threat hunting. You've been to our classes that Chris has been doing for free for coming up on a year now. And when you go to management and you say, hey, we want to do network threat hunting, basically you get shot down immediately. They're like, well, there's no compliance standard. We're seeing if ISO has this or NIST or any of these. And it's very difficult to actually get movement and actually doing really solid computer security if you do not have some type of standard behind you, some type of group that isn't just a bunch of people on a webcast talking about cats telling you it's a good idea. So that's the goal of this presentation, kind of designed to set up for you to build your command and control detection capabilities in your organization, your network threat hunting capabilities in your organization, and finally having some coverage from MITRE to actually be able to do it. Now, this is actually a slide out of my class, the Active Defense Offensive Countermeasures class, and I use it in the Intro to Security class and the SOC class. I use this particular slide a lot. And basically, it boils down to the concept of what allows different groups to win or lose. And this basically goes back to John Boyd, who was a fighter jet pilot, and he developed OODA, which is observe, orient, decide, and act. And one of the big problems that we face in computer security today is our ability to actually observe what's going on is incredibly limited. And we're going to discuss this in a little bit more detail about how we can use these different command and control frameworks and how we can actually use tools like Rita and Passer to develop better observations. And if we look at this from an attacker's perspective, they have great observations, right? They can do recon, they can use Shodan, they can run through a number of different services to find things out, like LinkedIn, users in your organization. They can look at built with and identify the technologies that you're using. And they can do all of that without actually sending a single packet into your network. And yes, Chu Bokan, I am really excited about the new Top Gun movie that's coming out as well. So they have great observational capabilities. If you look at defenders, a tremendous amount of what we do as defenders is basically us trying to purchase threat intel feeds, purchasing deny lists for IP addresses, for hashes, for domains, for URLs, and a lot of that information is actually very stale. So when we boil it down, everyone says, hey, we can observe through intrusion detection. And we're going to talk about how that is pretty much a problem moving forward in the industry, especially whenever we're dealing with TLS 1.3. And if we don't have solid observations as defenders, the ability to actually orient ourselves to the attackers trying to break into our networks, to the attacks that may be on our network, are incredibly limited. And based on poor observational data and based on poor orientation data, then our decisions and our actions tend to be flawed. And we really need to find a way that we can do better in the industry. And it turns out that MITRE has been working on this for quite some time. So intrusion detection systems, problems with intrusion detection. Years and years ago, Gartner released a report called IDS is Dead. And the premise around intrusion detection and the Gartner report was basically that intrusion detection is dead because we should be using intrusion prevention instead. It wasn't necessarily talking about some of the inherent faults associated with intrusion detection as it relates to visibility, but it was basically just talking, hey, why detect when you can actually prevent? And that set off a series of arguments for a number of years in the industry. But what happened is back then, if you go back 15 years ago, intrusion detection worked like a champ much of the time. Now, why did intrusion detection work? Well, if you go back 10, 15, 20 years ago, a tremendous number of our protocols were still clear text. You didn't have HTTPS adopted at the level that it is today. You still have protocols today like SMB and DCE RPC, which are basically sent over the network and clear. You had protocols like FTP, and you had protocols like Telnet. So if an attacker was trying to break into an organization, they would be sending their attacks through clear text protocols. And intrusion detection works really well looking for attack strings if encryption is not used. And this begins the problem. Whenever you have protocols, and you have 15, 20 years ago, and people were using Dragon and you're using Snort, and they were setting all of this stuff up, and intrusion detection was working, the kind of intro infancy of the computer security mindset and the industry as a whole really started coalescing around intrusion detection as a technology that is actually really super viable, because it was. Now, the problem is, because it was viable back then, everyone kept carrying it forward. And now you have intrusion detection, intrusion prevention is baked into just about everything. Almost all your firewalls have it baked in. But the effectiveness of intrusion detection, intrusion prevention has steadily declined. And it's declined because of the widespread of adoption of things basically like encryption. When you're seeing a large amount of encryption being used now compared to before, you're talking almost 100% of many of the protocols that you will see in an organization are running over HTTPS for standard users surfing the internet. You really don't come across a lot of websites anymore that are straight HTTP. So the ability for those intrusion detection systems to not just see attacks coming at an organization, but also looking for command and control has reduced. And yet we still have classes in security. We still have people that are writing books, and they continue to talk about intrusion detection as though is it every bit as valid as it was 10 to 15 years ago. So that worked great for years. Now it doesn't work so well. Also, with attackers can use encryption, right? Absolutely. And you'll have some vendors say, that's true. Yeah, encryption's a problem. But if you allow us to intercept and decrypt the TLS SSL traffic, then we're back to being able to see signatures. And that's not true. That's not true because many attackers will use HTTPS or SSL, TLS on their traffic. And then once you decrypt it, it's encrypted again. That's double secret encryption. Then as we start moving to TLS 1.3, the whole process of trying to do inspection is going to continue to make it harder and harder. So the point of all of this is we purchased and we bought into a technology base 15, 20 years ago that was working really, really, really well back then. Our mindset in the industry was, hey, this technology works, but as time progressed, it got worse and worse and worse at detection. So our expectations of the technology now far exceed the actual capabilities. And that means we have a blind spot. That means that there's a huge lag in the industry that we need to actually go through and start addressing as an industry. Now, that's not to say that IDS and IPS doesn't have value. It absolutely still does have value. A tremendous amount of IDS IPS technologies is based on deny listing certain IP addresses and domains. And as much as that doesn't work to detect a targeted, determined attacker, it still works great against your general run-of-the-mill malware, general widespread ransomware. It still has value. So we've got to find a way to try to break out of this habit and this mindset in thinking that a certain technology is still working the way it did a decade and a half ago and start looking at alternative technologies. So now the endpoint is kind of a counter example of network intrusion detection. Whereas network intrusion detection in many ways has been stagnant for a long time. If you look at the endpoint, about 5 to 7 years ago, it had to evolve, and it had to evolve very quickly. Our perceptions of antivirus, if you go back 5 to 6 years ago, were pretty much in shambles. Any pen tester that was out there could easily bypass signature-based antivirus, and they could do it at will. And we didn't quite realize as an industry how bad this was until ransomware started exploding. Whenever we started having systems start to lock down, when we started to have files start to lock down as well, immediately the whole concept of the failures of antivirus became immediately apparent and visceral for the industry. So you saw this massive migration from signature-based detection into heuristic-based detection, artificial intelligence algorithms. And they really kind of broke down looking at how processes interact, and they started looking at it as a story. Process X begat process Y, which begat process Z, which opened up network connection 1. They can start looking at how these processes behave, both with file execution, network execution, but also what they're doing in memory to develop better signatures and understanding of the behavior of that actual endpoint. And once again, your intrusion detection systems and your network detection and response technologies did not keep up. And to be honest, intrusion detection is rarely, if ever, a concern for most penetration testing firms. If we do see detections, and Joff, if you could back me up on this, but if you do see detections, usually it's because you're using a self-signed certificate, or you're using a Let's Encrypt certificate, or you're using a certificate that you just stood up the week before. But it's not based on the behavior, but it's usually some aspect around the encrypted SSL traffic. Wouldn't you agree?
Yeah, I would agree. I think it's usually a lazy attacker, right? If you're or a pen tester, if you're about to establish a C2 channel and you're using, let's say, a commodity C2 framework, and you crank off a Metasploit, HTTPS, a reverse HTTPS, for example, you're going to get caught because of the self-signed certificate that's in there. You're not going to get caught necessarily because it's encrypted. It's because you just didn't go far enough to configure an appropriate server-side certificate in there. The other way you're going to get caught is very common, is with second stage payloads, but that's going to be on the endpoint, not on the IDS.
Yeah, and on the network, we actually look at standard signature-based detection. It's almost not, it never really is a factor in what we're doing at all, really.
Exactly right.
So we need to try to address this, right? And once again, when I say we, the industry, and MITRE has. There's a bunch of people. Fowler has been working on Shield, and we're going to talk about that a lot more. There's some amazing people at MITRE that have been looking at the trends whenever they're looking at actual attackers, and they're dropping the techniques that attackers use into the matrix, the MITRE Enterprise Technique Matrix. They're seeing trends, and MITRE is actually taking steps to try to develop approaches for dealing with those different attack methodologies moving forward as well. And by the way, in May, we do need to set up a BHIS bingo game. Like, is this recorded? Are there certain phrases where John rips on threat intelligence that we can actually stamp in the bingo cards as well? All right, so let's move on. All right, so if we look at the MITRE ATT&CK Technique Matrix, and we look at how to handle MITRE command and control and exfiltration, unfortunately, there's not a lot of technologies that are effective at actually detecting these different attacks, right? Very, very few companies actually have the ability to test and actually assess their network detection and response capability for detecting command and control. So if you're looking at application level protocols, you're looking at communication through reversible media, which isn't on the network, it doesn't quite apply. Different types of encoding and obfuscation, resolution, encryption. These are all the things that are now basic table stakes for how an attacker will set up and run their command and control out of the environment. And when you're looking at the MITRE ATT&CK Technique Matrix, one of the things that I recommend is you don't look at the matrix from the perspective of how do we set up detects for each one of these different rectangles. Instead, how do we actually deny entire categories of attack techniques to an attacker? So this comes into being really, really important with MITRE Shield here in just a couple of seconds. So if we're looking at initial access, if we can actually start implementing application allow listing, that's going to deny the adversary a tremendous amount of capabilities. Privilege escalation and defensive invasion, getting to a good solid endpoint protection product. But if you get over here to the command and control and data exfiltration, once again, not a lot of really hot ways to try to shut this down in organizations. Once again, because of the level of encryption that's actually being utilized. So this makes us start to look at this and say, okay, how do we handle these two columns if we don't have signature-based detection, if we can't parse everything? And there are some ways that you could do it, right? One way that you can do it, basically start doing an internet allow listing. Identify what websites your users are allowed to go to and just deny everything else. I mean, that sounds like one of those situations where you would have pitchforks and torches after you if you did it. But I think that that's not as true as it was even 5-6 years ago. See, if you actually implemented a full internet allow listing approach, your users would still be able to get to their personal email. They'd still be able to get to Facebook. They'd still be able to get to LinkedIn. They'd be able to get to all the personal websites that they normally would. And the reason why? Because they have their freaking phones. So we're still kind of dealing with the mindset of, well, we shouldn't like lock down the internet because people are going to get mad. No, they're not. They have this magical device that allows them to go anywhere they want. And it's not on your network, which is the best part. So that's one way that you can do it. But politically, that may be somewhat difficult. So we're going to talk about some techniques and some technology that we've created at Active Countermeasures that actually help with this immensely as well. Oh, by the way, we got people from the MITRE Shield team on. I don't think Fowler is on today. I think on this she was called CF Fowler, but we have people from MITRE and we have people from MITRE Shield. So super excited to have them on, and we're going to give them lots and lots of props as we progress through this over these next few slides. So let's move on. So MITRE Shield, while we have two columns within the MITRE attack technique matrix and the enterprise side, the MITRE Shield framework is basically there to start addressing deficiencies in things that organizations tend to miss and traditional security technologies don't have the capability to actually handle. So if you're looking at recon, there's actually things in MITRE Shield dealing with cyber deception and active countermeasures that are designed for creating decoy accounts. There's a whole bunch for creating decoy credentials, decoy networks, going through and setting up, what else do we have? Network manipulation. But the big ones that we're going to be talking about here in just a little bit deal with the network analysis side of the house. And we're going to talk a little bit about why I think that actually made it in the active defense side. But that whole concept of cyber deception and actually utilizing active defense is absolutely monstrous for the industry, because it is literally the first time that any large-scale organization has started talking about active defense as not just a nice-to-have addition to computer security, but actually boiling it down to the point that this is something that is essential and it is necessary. And that'll be a different webcast where we talk about cyber deception and MITRE Shield. Instead, I want to focus on how MITRE Shield helps address the two columns of network analysis for command and control and data exfiltration, because that is critical, because traditional security technologies are failing us. So with MITRE and Shield, they have given us a number of different techniques that we can actually utilize that give us kind of a roadmap on how we can do this better. So the first one would be behavioral analytics, right? We can instrument a system to collect detailed information about process execution, user activity, develop a sense of normal and expected behaviors, and alert on abnormal or unsuspected activity, either accomplished on the onboard target system or by shipping the data to a centralized alerting system. Now, if we actually go down to Duke, that's what I'm calling the DUCs. If we go to Duke 0166, it says a defender could monitor anomalous behaviors for client applications such as atypical module loads, file read writes, or network connections. Now, once again, there are very, very few tools out there that are set up for actually detecting anomalies on a network. We're going to share some of those tools with you here in just a little bit, and they're free and they're awesome. If we go to Duke 212, we have a defender can detect the use of non-standard protocols by implementing behavioral analytics specific to a rise in protocol traffic to a set of systems, and one might be able to detect malicious communications from an adversary. And then 213, a defender can detect the use of external web services for communications relay. That would be something like domain fronting, by implementing behavioral analytics on what domains a system is communicating with, how frequently, and at what times a defender can potentially identify that malicious traffic. Once again, they're basically showing the way on how we can actually start doing network level analysis to start detecting this. But here's the deal. It's not a simple signature game. Everything that they talked about here in MITRE Shield is not like run an IDS system and detect a bad URL. No, it's not like that. It's not passive. It's going to require a little bit of work. We have PCAP collection, right? PCAP collection. We have DOS 116. There's an opportunity to detect an adversary that actively uses obfuscated communication. There is. We can actually do that through a variety of different heuristics and heuristics analysis on a particular network connection between two computer systems. DOS 170, there's an opportunity to collect network data and analyze the adversary's activity that it contains. Now, that would actually drop down into the level of actually looking at the actual signatures, but we also can look at the activity through the behavior of the network connections, how those connections are established, the size of those connections, duration of those connections, frequency and interval of those connections. And we can do that analysis today with free tools like Rita. So a wider view, one of the things I really love, and as I said, we have people here from the Shield project in MITRE. I love how they break it up to opportunities, use cases, individual procedures, and then specific techniques that this actually ties to. So once again, they're creating this framework that now it isn't just you saying, hey, this is a good idea. You're an early adopter. You're someone that may be an innovator, and you're just pushing through what you think are good ideas. We're now getting to the point where the idea of network threat hunting, we're getting to the point of active defense and cyber deception are now moving into the late majority. It's going to start becoming something that every organization should be doing. And I don't say this very often. I couldn't download the Gartner paper because now all of a sudden I have to register to get to it. But if you look at things like managed detection and response from Gartner, Gartner said if you're going to do managed detection and response, all good managed detection and response implementations should have two primary things: endpoint analytics and network traffic analytics. And I know this sounds weird. I agree with Gartner. It was bound to happen eventually here, folks. It was bound to happen. But with this, we now have the ability to start going up to management saying, hey, network analytics management, that's something Gartner says is important. Oh, by the way, MITRE also says it's important. And it's going to become the norm. So it allows us to actually get into the point, Banjo Crashland. Is that going to be a shirt now? Like it can have hell frozen over, and it can be like John agreed with Gartner, something like that. So there we go. So what's cool, once again, when we look at MITRE and Shield, is they're breaking it down rather than just specifically saying something. They're breaking it down to opportunities, use cases, and procedures to develop context around that concept. Oops. All right. Network monitoring, absolutely dedicated to network monitoring, right? If we look at the DOS 198, there's an opportunity to monitor network traffic for different protocols, anomalous traffic patterns, transfer of data to determine the presence of an adversary. And that is absolutely, honest to God, that is absolutely true. And that is something that we all should be doing right now. So why exactly is this necessary, right? Because I know that once again, there's going to be people that start communicating with management, and you're going to have vendors come in and they're going to say, no, we got this product. It's signature threat intel based. We got this covered because we're collecting all these IP addresses that evil attackers use. Honestly, if you're looking at what a lot of really advanced adversaries are starting to do, they're starting to piggyback their communications for their command and control on top of quote unquote legitimate services. So on the left of your screen, this is a tool called GCAT. GCAT was originally written by Ben when he worked at Black Hills Information Security as an intern, was taken over by Bike Leader or Marcello, who's oddly enough not on this webcast today. But it's a command and control framework that allows you to establish full command and control through well-formed Gmail messages. You can run it through Google. There's other projects out there that'll use Google Sheets. There's projects out there that'll use Office 365 accounts to set up the command and control. So you're getting to the point where that level of detection becomes a lot harder because they're riding their command and control over what we consider to be legitimate traffic, or somewhat legitimate. Another tool by Dakota is Sneaky Creeper, and it can communicate over Twitter and Salesforce and a number of other different services, once again, in an effort to try to blend in. It's not as simple as just saying, hey, these IP addresses are good, these IP addresses are bad. Boil it down to domain fronting. Yeah, that's still a thing today. Even though a bunch of vendors said that they were going to get rid of it like 5 years ago, it still works. We're still using it. So that command and control just based on IP address and looking at domains is really, really hard for anyone to try to implement in their organization effectively against a targeted, determined, and well-trained attacker coming at your organization. So it becomes absolutely necessary. So I want to get Keith up. And if Keith can jump on here, I want to give him some props. One of the things that he has been working on, and this is an amazing project, and I think for all of you, this is an amazing way for you all to get involved, is the malware of the day, right? So if you go to the malware of the day, and let me get a link for everyone, and I'll share it in the Discord channel. Really quick. There we go. He's going through a lot of the malware that exists in Cobalt Strike, and kind of some of the tools that you can use. We'll be going through hey, we've got George on. George, can you give us a link to the C2 framework that you're working on? Because that's another cool project that deals with this too. We want to talk about that. So if we go into malware of the day, Keith, what is your overall approach for kind of creating the malware of the day? I have it up on the slide. You can kind of talk about what you and your team are doing to create these and share them with the community.
Absolutely. Primarily, what we're using as a tool is Cobalt Strike. And we're using profiles that are trying to emulate real malware that has been found out in the wild. And then we're capturing the network traffic by running these malware replications. And our primary goal here is to capture that network traffic and share it with everybody out in the InfoSec community. That way they can run these PCAPs that we generate through their own tools for testing their current defenses and to see how well or unfortunately maybe, how not so well that these are detected. I'd like to also put a shout out to George. He's been very helpful in this project as well. We do have one that we did on Orange Worm using Scythe, and that worked awesome as well. So, and the other thing we're doing here is we're running these through our tool Rita, and so far Rita has really shown to be an effective tool of finding this type of beaconing behavior.
Absolutely. And like you said, we're giving the PCAPs. And one of the things I like about what you guys are doing is we have the 1 hour capture and the 24-hour capture. And I think that that's really nice, because if you just want to pull it down and play with it, it's 1.8 meg. If you really want to look at a long-term analysis on it, it's like over 100 meg. The other thing is you're not just running like just our tools, but you're actually, for a lot of these, you're breaking down the certificate information. You're going through and getting IP address information. You're diving into the actual packet captures with Wireshark. It really kind of shows about how well you can actually use this as a real learning environment. I got Jay Haprens is asking about JAW3 signatures. And yes, JAW3 is in Rita. We'll talk about that here in just a little bit, but it's in there as well. So just a tremendous job. So hats off. I wanted to bring Keith up and show everyone Keith and all the amazing work that he's doing, and also his amazing space cat in the background. So thanks, Keith.
Thank you.
So the malware of the day is a place where you can start learning, right? You can start running this through various tools. And if the tool is detecting just on an IP address, but it's not looking at the behavioral anomalies, then we've got a problem, right? Because all an attacker has to do is just shift that IP address off to a different IP, and then the detect is gone. There's a previous webcast that I did where we talked about threat intelligence and the difference between durable and ephemeral threat intel. And if you're just detecting on IP addresses, domains, hashes, that's ephemeral. The attackers can basically switch that out very, very, very quickly. So here's an example. You talked about back off as one of the malware specimens. And somebody asked earlier, how does Rita and these tools deal with jitter? And that's a great question. We'll talk about that in a little bit more detail a little bit later, but it actually works really well. We're going to talk about the nature associated with jitter, because many of these profiles will actually incorporate Cobalt Strike jitter into it, usually between like 10 or 20%. And I'm going to talk about some additional detection technologies that you can utilize, like long connections, here in just a few moments as well. So Keith talked about Rita, and I wanted to talk a little bit about why we created Rita. Now, a number of you have been on webcasts. You've heard about me talk about this. Some of you are new. And what Rita does is it identifies these types of anomalies in a network. Now, Jonathan Ham, I was on a call with him. We're working an incident right now for one of our SOC customers. And the beautiful thing that Jonathan said on one of the calls is he said, not all anomalous traffic is evil, but all evil traffic is anomalous. And I think that really kind of sums that up. So what exactly is Rita? How does that actually work whenever you're dealing with something like Cobalt Strike and jitter? All right. So whenever we're looking at those MITRE kind of breakdowns, talking about abnormal traffic and anomalous traffic, that's exactly what Rita has been doing for a while now. So imagine that you have a backdoor, okay? And that backdoor communicates at we'll start with a basic one, a very regular interval on the network. All right, so let's say it's 10 seconds. So every 10 seconds, it's making a connection. What we can do, like Subho Khan says, there's math. We're coming to that here. So what we can do is we can analyze that traffic for consistencies. Because believe it or not, consistencies are anomalous. A human being going to a website, clicking a link, that's not going to be all that consistent. They're going to go to one website, then another website, then another website. Even if the website reloads, it's going to load, and it's going to load a number of different advertisements from different places. Inconsistency is actually normal in that situation. But if you have something that's beaconing out at a perfect heartbeat, it makes it easier for Rita to detect it. So since we're joking about math here, I'm going to talk about this. So k-means clustering is not the algorithm we're using. It's a cousin. So this particular algorithm is designed to actually identify consistencies within data sets. It does not handle outliers well at all. So if you have a beacon that's every 10 seconds, and then all of a sudden one waits 2 hours, then it's going to completely blow k-means clustering out of the water. So instead, we use a cousin called MADMOM, which is median average distribution of the mean. And what we do is we look at things like the connection intervals to look for consistencies. We look at things like the data size to look for consistencies. And we also look for skew and dispersion. Let me explain that. So let's say that we have a backdoor, all right? If we have a backdoor that has 10 second as its interval, but it's plus or minus 20% for jitter and Cobalt Strike, that means the connection can be anywhere between 8 and 12 seconds, random. Now, if that's random, that does some magical things that we can detect. The first thing that it does is you're going to have 50% of the connections will be between 8 and 10 seconds. And then 50% will be between 10 and 12 seconds. That creates a balanced dispersion. So we can detect that as well. So even if they're trying to be creative, it once again creates another way that we can actually detect that. And that's what Rita does. So you can see here, let me actually open up a VM that has a Rita report. Here we go. Should be able to see that. Every connection or like connection breakdown actually has a score. The closer that score is to 1, the more perfect it is from a consistency perspective. Either consistent in its interval, consistent in its data size, or consistent in its skew and its dispersion. In this one, we have a score that's 0.997. That's a really strong score. The one outlier associated with this connection is we have a really good, strong score with its consistency for Madmon. We also have 4,532 connections that were made. So we have lots and lots and lots of connections, and we have a really strong consistency score. This would be something that you would want to analyze in your organization. Is there a write-up? I don't think there's a Wikipedia article for median average distribution of the mean, but here's the deal. The code is open source. It's in READIT. It's written in Golang, right? So we are able to actually look at things like skew and dispersion as well to make a determination that no, this is actually a very regular heartbeat leaving an organization. So another one of the analogies that I use all the time is imagine that you have a small child trying to get your attention, right? They will say, or somewhat a parent's attention. They will say, mom, 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 or dad, 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 dad. That is a beacon. It's very consistent in its interval. It's consistent in its data size as well, all right? So that works really, really well to do this type of detection. And we've had the link shared out a number of times for Rita, and you all can check that out here in just a little bit. Also, as I mentioned, Keith goes into a lot more detail for a number of these captures to actually get into the PCAPs and explain it through Wireshark, identifying certain strings, SSL certificates, so that you have a better understanding of how the malware actually works. And then finally, you can download it. Because as George says all the time, PCAPs or it didn't happen. We want to give people the ability in a safe way to play with malware network traffic so they can see different ways that they can actually go about trying to detect it. Now you need to do analysis of a child saying mom, 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 mom for 24 hours. I think I've been there, right? So there we have a screenshot of Rita. I wanted to bring Bill to talk a little bit about Passer, because a big part of doing that network analysis is also understanding what is on your network. So you might have a system that's beaconing very, very, very quickly, and you find out it's a DNS server. Or you might have a system that's beaconing like video cameras back to Guangzhou, and you want to find out what those are. How can you actually identify what those devices are? And Bill has written a tool that's free as well called Passer that you can use as well. So Bill, do you want to talk a little bit about Passer? I think he's on mute.
That would never happen. Not a chance.
There
No,
we go.
thank you, John. Absolutely. Passer is a tool that we make available for free. It watches on the network for live packets, or it'll work off of a PCAP file if that's easier for your security policy. The goal is to identify the hosts on the network, what type of traffic they're taking part in. We go down into the payload to look at the operating system and the software being used and the versions. We try to give you a picture of what's running on your network at this moment, partly because I want to be able to do a kind of an inventory of the systems. I'm happy to acknowledge there are tools that do a better job of this. There are commercial tools that just are slick and keen, but Passer outputs all of its information in comma-separated format that makes it easy to import into other tools, pull it into a spreadsheet, import it into a database, type away with grep, sed, and awk if that's your particular style. And the end result is you get a very good picture of what's on your network, what ports are being involved. It really is kind of a tell me about my network state with as little headache as possible and as little configuration as possible. We have a webcast that
Robin already dropped it in.
Oh, wonderful. Thank you. Great. So there's a link to the YouTube video. Thank you so much, Robin. Appreciate it. And so if you want some more information about how that works, you can go and watch that webcast. I'm going to give one quick note to the people watching this one. Since that came out, I've released the multiprocessor version as well, which has a lot of features you just cannot put into a single process packet sniffer. So
Very
if
cool.
you're interested, check out the Passer NG branch over on our GitHub website.
And we'll drop a link to that in the Discord channel. Subu Khan also brought up, sorry for the redundant question, but as passer, does it need a span or mirror port? It helps a lot, right? Because we want to get as much of that traffic.
Yep. Without it, you will see the traffic coming in and out of this system, and you'll learn a little bit from the broadcast packets, but you get a much more rich picture if you can get a span or mirror port, and that can be a very inexpensive device.
You bet. You bet. Thank you so much. I appreciate it, Bill.
Thank you, John.
I feel like I'm trotting everyone out. It's like, here's some free stuff that Keith did. Here's some free stuff that Bill's doing. Once again, proudly sucking at capitalism at work, right?
There we go.
I want to also take a couple of seconds and I want to talk a little bit about, testing this in your environment. George gave everyone a link to his C2 framework. And hopefully he'll post that out again. But I also want Joff to talk a little bit about actually creating your own implants. This is a little bit of advertising for a class, and we will have webcasts that are free. That we're going to talk about this too. But Joff, do you want to talk a little bit about different ways and different types of connection profiles that people can actually create in their environments for command and control?
Yeah, sure. So, yeah, what John's showing is actually a slide directly out of the upcoming class that I'm developing. This is part of the slide deck that I'll be putting over to the students in January. And, to John's point, when you're doing C2 out of a network, it is very, very common these days to use TLS because there's one thing that you can actually nearly guarantee in almost all cases, unless you don't have a network at all, and that is that a TLS web connection will 9 times out of 10 be able to egress that network. So in order to create a C2 channel using HTTPS or TLS over TCP port 443 on the network is a really easy and near guaranteed way to get that communication out. So what you're seeing on the screen here is a pretty short C# sample of how to set up an HTTP client that's using TLS and putting a couple of headers into the connection profile, if you like, when you create that code. And that is, we're going to create an HTTPS connection, and we're going to send application/JSON as the media type, and we're going to put in a random user agent into the headers. Now, when I say random user agent, what I'm really referring to is go to something like useragent.com, select the top 10, and then pick one of the random top 10 most commonly used user agents, right? So we're going to blend in with the traffic pretty well. And then I've got a dead giveaway here in my, this comes from my own custom C2 framework that I'm actually going to give away to students as part of the class. So there you go, free advertising there. There's an API key associated with the framework, which is introduced in a header in the initial HTTPS connection. Now, when you're modeling C2 traffic out of your network, aside from sending it over TLS, using something like JSON makes it pretty easy to transmit the command polling request and response that you need in order to get the client-server communication for a C2 channel working. If you really think about this, and actually, John, I think it might even be on the next slide. If you really think about this, the steps when you're actually communicating over TLS is, oh, actually, it's not on the next slide. My bad. It's on a previous one. So let's not worry about it. It's, oh, there you go. One down. There we go. Perfect. Is really to make that connection out of the network, perform some sort of HTTPS post to register as a new C2 endpoint with whatever the C2 framework is on the other end, and then just drop into a loop. While the connection stays up, we need to get a command request from the server side, which is the attacker side. Once we receive that request, let's say it's in a JSON array, we execute the command on the victim machine, we put the response back to the server. That's the essence of a basic C2 connection. This is why they have a beaconing nature, as John is referring to, because there's always going to be this continuous poll where it goes back to the server and says, hey, give me a command. The victim machine executes it and sends the results back to the server again. Sending that over TLS, of course, is a natural thing to do, and that's what you want to do. TLS 1.3 makes that a lot more difficult because of the additional security mechanisms. And furthermore, it is not beyond the realm of possibility that a C2 channel author goes ahead and does something like certificate pinning in their application so that there's no way that you can actually intercept that traffic and get plain text, which makes network analytics absolutely essential in analyzing any of these C2 channels.
Right. So thank you so much. I appreciate that. And if you want to look at more frameworks, this is George's C2 matrix. So the point of this slide or this particular website is, folks, we have options. You have lots of tools that are out there that you can use to emulate a tremendous amount of network traffic that malware uses. And you can start testing your security technologies today to figure out whether or not they can start detecting these. The point is, from the beginning of this presentation, we talked about signature-based detection. We focused on signature-based detection for so long that we started to actually ignore it after a while. And now we have this huge hole. And it's up to us as security professionals to start testing these things out and start running them. And this is just a great way that you can work with a lot of different existing command and control frameworks to test and evaluate and do adversarial simulation. And of course, we're going to talk about Joff's class and some webcasts coming up a bit later, getting you to the point where you can start creating your own command and control as well for trying to do that adversarial simulation. And this is essential. This is key. And the reason why this is key is because if you start looking at a number of different CERT like alerts that they're releasing, they're actually going through and they're listing out all the different MITRE techniques that are being utilized, including many times the command and control that's being used. And then sometimes they'll break down and they'll say, well, this is TrickBot, and it's using DNS to actually communicate out of an environment. And once again, tools like Rita, right here, has the ability for us to actually dive in and look and capture DNS traffic. So like here's an example of a DNS backdoor. And this is called nanobotninjas.com is the evil domain. And how we detect it and how Rita detects it is it has 23,780 subdomains. We can detect malware by like TrickBot and Ryuk and all these different malware specimens that are out there. We can actually detect that. The other thing that I saw show up a bunch was JAW3, and Rita does also support JAW3 for looking at SSL fingerprinting. You can actually check that as well. And I'll show that maybe a little bit later after we're done with this particular part of the webcast as well. So let me bring the slides back up. There we go. So some kind of parting thoughts for this, right? So we fell into a rut with intrusion detection. And now we're kind of at the point where we need to start evolving our network intrusion detection capabilities. And we need to start evolving it in the same way that we did with the endpoints, where we started looking at heuristics and trying to do analysis on the behavioral patterns of nodes within the network. And for a long time, this was considered to be a pipe dream. They're like, oh, well, going through and doing analysis for looking for consistencies in network traffic, that's really hard. I'm here to tell you, yes, it's really freaking hard. We've spent a lot of money. We've had a lot of people working on this, but it works and it's fast and it's free and all of you can use it, right? So we need to start practicing. You have the C2 matrix. You have the ability to create your own malware. You have PCAPs that you've gotten from Keith. You have Passer that'll allow you to go through and starting doing inventory in your environment. So these tools are free and they're available right now. And finally, and I can't stress this enough, we finally have a call to action from MITRE. You know, there's been a bunch of us in this industry that have been talking about these things for a long time. And we just needed an organization to stand up and say, look, this is something that we need to do. And hopefully now we have that call to action and now we can start getting management to move with it. out there as well. So I hope you all give a big round of applause and thanks to people like Bill and Keith, developers at Active Countermeasures, but also the team at MITRE, because they're going to be taking point on this politically moving forward. I did want to share a link for Rita, or open up the site for Rita, so you all can download Rita today, and you can actually have it up and running very, very quickly. If you have a box that's ready to go, the install script, it just runs, and it works really, really, really well. So here's the link for Rita. There you go. And then you can actually go straight to the GitHub repository and you can run it as well. So I want to open it up for questions. I saw that there's a lot that's going on right now on Discord, but let's open it up for questions. We have a lot of cool free tools that we can use. Hopefully we'll see some more free tools. By the way, one last note, we do have 26 different patents for Rita. And we specifically did the patents for Rita so that Rita can remain open source and free. I don't want some large scale vendor, like I'm just going to pick on Cisco, coming up with a patent for what we're doing, and then basically saying they're the only vendor in the world that can do this. We want to make sure that what we're doing with Rita and what you want to implement Rita, you can do it for free in your organization. We have it completely locked down and we protected it from a patent perspective. So it's all out there.
Hey,
Do we have
John,
an article write up for Mad Mom? I saw that one pop up a bunch. I do not have a direct write up for Mad Mom, but the actual code is in Rita, and I don't know the exact file that it's in, but it's actually pretty well commented. But we do actually have the source code that people can actually pull it down as well.
Hey, John, I wanted to just drop one extra comment, which I forgot to drop, and that is, if you are not looking from a defensive perspective at your content distribution network traffic, you need to start looking, because a lot of the C2 channels, I can tell you, I did it in the past like 4 or 5 tests. A lot of the C2 channels are going straight through content distribution networks.
Absolutely. Also, we're going to stay around. We're going to answer some questions. I'm loading up something else here. If you want, I want to make sure that this is always completely open, that we release all the free stuff. The webcast is free. Everyone knows that that's free. I'm going to transition into a demo of our commercial product, okay? Probably here in about 10 minutes, I'm going to make that transition. But I want people who are worried about a demo, like a vendor doing a sales pitch, that are like, I don't want that. You can leave. And that's perfectly cool. We're giving you an opportunity to get out of here. I don't like to do this stuff at the beginning. I hate it whenever I do a webcast with a vendor and the vendor talks for 15 minutes at the beginning. We're going to talk about how you can do this with Rita with a full visualization, alerting, and analysis package from AI or AC Hunter is what we're actually renaming it. So let's go ahead and let's bring in the questions. Shelby, do you see any questions that caught your eye?
There are some coming in right now.
All right.
Let me see. Bill's been answering a great deal of stuff coming through the GoToWebinar side.
Yeah, he just pretty much nails them right away.
Oh, yeah.
My Zeek environment does 1.2 million events per hour. They go to Elastic together with our Saracata events, packet beats and events and some flows. What's the best way to integrate Rita with that? So your Zeek installation, you have your Zeek, wherever your directories for your logs go. We just need to basically set up Rita to pull those logs. Specifically, what it looks at in Zeek is it looks at the connection, the DNS, the HTTP, and the SSL logs. So as long as Rita can get on that system where Zeek is running to pull those off and do analysis, it should be just fine. Now, you don't want to do beaconing analysis in Elastic. I cannot stress that enough. Elastic is amazing. But if you say, hey, I want to pull 1.5 billion records from your Elastic cluster so that you can start doing analysis on it on a large scale basis, your Elastic cluster is going to basically flip you the bird, lay down, and take a nap. So you can't do it directly off of Elastic, but you can pull it directly off of your Zeek system as well. Yep, we did step away from Elastic. We actually went to Mongo. Getting network telemetry for this type of analysis is a work from home environment is a challenge. Any Rita-friendly solution? So yes, right now what we're working on, and I know that this is phantomware, but we're actually working on the ability for doing beaconing analysis from Sysmon Event ID 3 logs. If you know, we have a free project I didn't talk about here called Beaker, and Beaker allows you to ingest Sysmon data and correlate that with Rita data down to the endpoint. We're now working on a project, Logan and Naomi are working on that right now, where we can actually pull the data from Sysmon and do beaconing analysis. It is not as rich as the Zeek data, and it's not as accurate, but it does get you into the ballpark for that as well. So, okay. So used to have Rita, but it has a hard time doing it for every log every day. Got to give it more CPU cores and more memory. Big boats. To go fast, you need big motors as well. All right. And actually, the way you can actually set it up is it'll actually run every hour as your Zeek logs roll. And it always does that sliding 24-hour window for doing the analysis out there as well. All right, Shelby, I'm watching Discord. Did we get any more questions from the GoToWebinar crowd?
There's only 2 GoToWebinar questions I haven't seen Bill answer. First one is, so providers like Akamai are not looking for this kind of C2 stuff?
Akamai.
Yes.
So, no. So whenever you're looking at Akamai or you're trying to bounce off of things like CloudFront, a lot of those vendors, if an IP address is flagged as a malicious C2 IP address, they will shut down that traffic. But by and large, they tend to miss a lot of it. And honestly, they're passing so much data from point A to point infinity that it's almost impossible for them to do full packet and beaconing analysis. I would never expect them to do. I'm not going to hold it against them if they don't. It's just they're dealing with a tremendous amount of traffic as well.
Cool. All right. And the other question, there might be some context missing, but it's how do you get that? I've seen it go through CDNs, but how do we understand data that is going to CDN and get that information?
So one, if it's encrypted, you're not going to be able to see that raw data. And that's a key point. With Rita, it's not actually trying to decrypt the traffic and analyze it. It's looking at the data size. It's looking at parameters that have nothing to do with the content of the actual payload itself, other than like URLs, domains, things of that nature. So that's the key, is we're looking at the behavior of what that traffic is actually doing, not trying to actually do analysis just exclusively on IP address or trying to dig into the content itself as well. Now, another cool framework is Flare. That one just popped up from Austin Taylor, and I believe that Flare integrates in with Elastic, and specifically it's looking at HTTP connections for communications, and I believe it's written in Python. It's a pretty neat tool to play with as well, so it's pretty cool. All right.
Awesome.
All right. Any other questions?
What strategy do you attack persistent C2 communication, e.g. malleable? I'm definitely not pronouncing that right.
Malleable.
Thank you. C2s set up to beacon once a month in case other channels have been compromised.
So so that's actually really, really cool. We actually had an incident a couple of months ago where we had one system that was beaconing pretty regularly. We knew it was compromised. And I'll just show you real quick. Let's say, I don't even know what data set I have. I guess it doesn't matter. So this is AI Hunter. So with this, we can actually go deep dive. And one of the things that we found out is that one system was beaconing very regularly, but we had like 3 or 4 other systems that were beaconing out once per day to the command and control server. And they basically were backup channels. I mean, you can actually dive into that and you can actually basically look at those connection profiles relatively easily. So like here you have, this isn't an actual attack beacon, but it shows the idea. So we have this system right here, 192.168.99.52. It has a pretty good heartbeat right here, but this other system on the environment, they have the same heartbeat. At any rate, you would see like 1 packet. So that's how we can actually do a deep dive to actually drop into that network communication and say, look, we've got a very regular beacon here. Now we can actually dive into that beacon and say, are there any other systems that are talking to that IP address? And we make that super easy to do. Well, I want to say thank you very much for attending. I really, really do appreciate it. And as I said, you got a lot of free stuff to play with. But this is cool. This is one of those wide open green field spaces that so many people in security aren't playing with. And it kind of becomes a cutting edge place for many people that are just getting started in security to start cutting their teeth and kind of working on something new. So that's just great. All right. So with that, we're going to officially kill the free part of the webcast, and I'm going to transition and I'm going to show the people that want to see AI Hunter, how AI Hunter works and how we tie this stuff together in a way that actually is cost effective and saves people lots of time and effort and blood, sweat, and tears. So thank you so much, everybody. So we talked a lot about RITA and that network analysis and that network level detection. I wanted to take a few moments and show you AI Hunter. And by the way, one of the things that I want to get across very, very, very quickly with AI Hunter is it's not like crazy expensive. We try to make sure that our price for this is cheaper than the sales tax for some of the tools, like if you're going to run Darktrace or ExtraHop, we're pocket lint compared to some of those products. But we do stuff they don't do, which I think is cool. So we talked about beacons and doing beaconing analysis for detecting malware. So here is actually a really, really good beacon example, right? So in this beacon example, you can see it has like 99% score, the dispersion, the data size, the skew, the connections. Look at that histogram. The number of connections per hour is 120. This thing is perfect. This absolutely is something that you should be looking at. We can look at the connection intervals, 983 at 28 seconds, 1,000 at 29 seconds, 800 at 30 seconds, and 420 at 27 seconds. That's a really strong beacon in an environment. This particular beacon has done no crack at all, which is great. If we look at the data size of it, we can also see that there's a very strong frequency at 8,859 connections with a payload of, what do we have? 8,000 or 889 bytes. So that's what RITA does. And this is a great way to visualize what RITA is doing, because RITA is actually under the hood for this. RITA is what's driving all of this. It puts it out. RITA's output looks like this. Let me go back up here. If we go back to just beacons, this is what RITA's output looks like. Okay, it's breaking down and it's saying, okay, we've got the number of connections, we have the mode, the size, the skew, the interval, we have the dispersion, and that's just raw output. But with AI Hunter, it actually breaks it out visually so you can actually see what it is actually doing. So we have this very consistent frequency. We have this very, very consistent data size. This is a great beacon. The other thing that's really cool is AI Hunter has the ability to integrate with Sysmon data. We also integrate with Carbon Black and a bunch of other tools. So if you want to dive into this and say, well, we have this frequency, it's going out to DigitalOcean, what is that? You can click the little beaker and it's going to jump you straight into Beaker. So with Beaker, we can integrate that data from Sysmon, with Sysmon, so that we can get additional details as far as what that connection actually is. So here we have our source IP address 192.168.99.51. Destination is 104.28. We have that flat histogram with the number of connections. It's not per hour. I can't remember if it's per minute, every 10 minutes. And then down below, we can see the executable is a PowerShell executable. It's ran by Jean-Luc Picard. And then we go down a little bit further and we have the raw Sysmon data as well. So this is a great beacon, right? And this is amazing for actually detecting evil on a network. Now let's talk about a beacon that was created by a crack-added squirrel. It just so happens that I have said crack-added squirrel or crack-addicted squirrel on the webcast with us. So Joff, this was a special beacon that you created for demo data sets. Do you want to talk a little bit about what this nightmare actually is and what it's doing here?
If I could remember.
You did process injection and you set up jitter and randomization to help out.
Oh, right.
Specifically, you injected into Runtime Broker. So there we go.
Yeah. So we injected the beacon into a system process on the system. Now I'm trying to remember. Let's see, Keith. Did you run my custom C2 code, or was this
yeah?
Or
Yeah, it was custom C2 from you.
custom
dot
C2,
section.
right.
Yeah.
Yeah. So you can with injected shellcode, we're going to see characteristics that are specific to that particular shellcode, but the process side of it is going to look a little bit different because the process is randomly chosen from a list of processes that the user owns, and the process that actually did the original injection actually disappears, right? Which is pretty common for. Well, it doesn't disappear; it just terminates, right? And that's pretty common for a lot of a botnet or fileless malware, if you like. I hate that term, by the way, fileless malware, but it is a very common behavior for it to inject into some sort of process, and then whatever the user did to trigger that event, that original process ends. And in some cases, the process that you inject into or the process you create actually gets reparented to another process, which from an endpoint perspective makes it a lot harder to actually work out what's going on.
And in this situation, I like it whenever I talk to you and we talk to some of our customers and like, so what's the process it injected into? And you're like,
I don't remember.
One of them.
Or I don't know.
I don't know. And then we have customers, whenever we're using things like domain fronting, it's like, what's the IP address it's connecting to? It's like, I don't know.
So in advanced sort of engagement, it's not unusual for me to use a technique like this and not only inject into a process that the user owns and is randomly chosen from the user's process list, but also to send the traffic through AWS CloudFront, right? And so when the customer comes back and he goes, well, what's going on here? You say, well, we can track back in the logs on the C2 server and we can probably supply which process was injected, but it takes a little bit more work. And this stuff's sneaky. I mean, it will work. It's a very good way of threat modeling. It is very real world in the way that it operates.
Yeah. And there's some things that I love about it. This right here, the dispersion, like this is a wide dispersion. It looks like the middle is 35 seconds down to like 23 and then up to 45 seconds. But this is, once again, Rita can handle this. Like if you're using this type of dispersion for the command and control, Rita looks at that and it balances and it's like, well, the skew, it's not really skewed one way or the other, right? We don't have a fat head or a long tail associated with it. And then the data size is also pretty consistent as well.
I love that concept. I love that concept of the dispersion and the skew, because I can tell you folks, this stuff actually works, because if you are in the process of authoring a C2 channel and you think about jitter, what you've got to do is actually create some kind of random value. And the only thing you can do as a code author is add or subtract that random value each time the polling occurs to the current static sleep period, which means you are going to get the jitter that is basically plus or minus around a center of a distribution, which is exactly what Rita is designed to catch. It literally takes that into an account. And there's very few other ways to actually do that jittering without making your C2 channel almost inoperative. I mean, you can actually go further and have much more of a random sleep period, if you like, but there comes a point where you can't use the channel, right? And it turns into a backup channel, which John was referring to earlier.
And we see that, right? I mean, attackers do set up backup channels. It does happen. Now, it is kind of funny, Joff. There are basic beacons that more or less shatter their connection profile. So like they'll nail up the connection for 10 minutes, it'll be established, and then it'll reestablish and run for 30 seconds, then it'll reestablish and then run for 5 minutes, and then it'll reestablish and run for 2 seconds. And the way that Rita actually handles that is by looking at long connections. And right now in my data set, I don't have any like long connection data there. What do we got here? But what happens with long connections is Rita is able to look at those really weird timed connections and say, this connection is really, 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 really randomized, but it's been in communication nonstop for 24 hours. So you can actually see that completely. Now, some people were talking. Oh, go ahead.
Oh, I was just going to make a comment that you just nailed the exact other algorithmic choice that as a C2 channel author I would choose, and that is to beacon for a short period of time, several beacons in a row, then to go quiet, and then to do it again. And also, I think people should remember that randomness in a computer is always pseudo-randomness. There is nothing that is ever truly random. And so randomness itself is an algorithm. And so anything that's an algorithm is clearly going to eventually be detectable. Just a matter of using the right approach.
Absolutely. And we had some people asking what normal traffic looks like. So let me show you, because you're going to have beacons that happen in your environment. And we actually have whitelists that you can ingest for updates and like DNS and NTP servers. So you can filter out a lot of the standard beaconing traffic that you see. So here we have a malicious beacon. Here we have Joff's malicious beacon. Here we actually have this one is actually an update server that gets wiped away with our whitelist, but watch the connection count. So what happens with a lot of these different like data sets is you drop off very quickly and you start getting like 20 or 30 or 60 connections for very, very limited times on an organization. So that's how that looks whenever you have that drop off to normal traffic. Now, the dashboard is the other thing. I'm not going to go over everything. We do beaconing, we do strobes, long connections. We integrate with threat intelligence feeds. So if you have a threat intel feed that you like, we'll actually automatically cross-reference whether or not your connection is going to a bad IP address online. I don't know if we have any data on that there. DNS, once again, that DNS cat, there's no DNS cat traffic here. We do have a data set that's DNS cat. But then some other people were talking about JA3 or J3 from Salesforce. We actually integrate with that too. So we actually have those JA3 signatures tied in, and we can actually do some identification as to whether or not a signature itself or a certificate is rare in an organization. And all of that rolls up into an overall score. The final thing that happens is when you have kind of cleaned up some of the false positives, you can go through and establish a score threshold. You can say, look, anything that gets a score of 90 and above, I want to have a syslog alert. And AI Hunter can send an alert to your SIM and notify your team. So you don't have to be sitting here looking at AI Hunter all day long, trying to find evil on your network. Finally, last thing, because I'm losing my voice and I'm hoping you all, set up a demo at some point later in the future, because I'd love to sit down and answer all your questions. Our pricing is stupid. I know our pricing is stupid. I sound like a used car salesman. Come on down to Crazy John's. But a couple of things about our pricing, I think that's important to get across to people. One, as I joked, our pricing is cheaper than the sales tax of a lot of the other products out there. And why is our price cheaper? Well, we eliminate the middleman. No, it's not actually true. But the reason why our pricing is cheaper is because we never took VC funding. So this is completely self-funded by Black Hills Information Security. It's created by pen testers, it's created by attackers. This is what we do for a living, to basically make our lives hell. So I don't have somebody in a big fancy car and a suit that's worth more than my house breathing down my throat to try to meet sales stretch goals. Basically, we're trying to get this out there and make it easy for people to do. You have the free tool in Rita. So if you're looking for a proof of concept, you got it. You can absolutely go and use Rita at no charge. And Rita does a lot of the stuff that we talked about under the hood. Rita's the engine. But if you want analytics, you want data visualization, you want the ability to deep dive into Sysmon data with Beaker, if you want to have the alerting notification, you're going to want AI Hunter. And it really makes my life easier out there as well. So how big of a pipe can Rita and ACM handle? I think Bill, I think we can answer that, the size of the pipe that we can't handle. We had a customer that tried to throw 100 gigs at our network, at Rita. Turns out Rita can't handle 100 gigs. Technically, it probably could. If you gave it enough spinning, or gave it enough solid state drives and memory and CPU cores, it could handle it. It's written in Golang, clustering is built in, but that's a beastly box that you would have to build. But under a gig, no problem. That's commodity hardware. You start getting into 5, 10, 20 gigs, 30 gigs, your bigger issue is not going to be Rita, but it's going to be the network adapter and configuring your system so it works. So here's a good rule of thumb. If Zeek can handle it, Rita can handle it. Just give Rita and AI Hunter the same specs that Zeek's working with, and it can process that data. Because really, Zeek is doing a tremendous amount of the heavy lifting and actually doing the protocol decoding, the parsing, and then dropping it into log files that we actually do the ingest on. But yeah, we have customers that have 5 gig networks. I think we have one that's running a 20 gig network. I don't know if they got it completely set up yet, but no, it can handle the data that you throw at it. You just got to give it enough CPU cores and enough memory, and it'll scream through the data. So in fact, this is kind of goofy. I don't know if we ever got it. Bill, I don't know if you're still on. Did we ever get it set up with actual instructions to get it set up on the Raspberry Pi? I know that we had some issues with the package management for like Mongo, but Rita is smart enough that whenever it's like Zeek has a really high CPU load, Rita won't process. It'll wait for Zeek's CPU load to go down, and then it'll start doing its processing. So it's constantly balancing its CPU cycles to get it out there as well. All right.
The quirk in January when I did the original talk on the Pi was that the Raspberry Pi was a 32-bit OS. It does now have a 64-bit OS. And while I haven't gone back to actually go end to end, and I know we have a couple of quirks in the installer we have to work around, I'm reasonably confident you should be able to run Rita, Mongo, and Zeek all on a Raspberry Pi, and you can watch the little thing scream.
Help, help.
Basically, yes.
All right, everybody. So with that, so Shelby, did I forget anything? Like I said, if you guys want to do a demo, go to webinar and type in demo, and we will reach out and set up a demo with you in the next couple of weeks. If not, think about it and get back to us. I love doing demos and showing people and answering people's hard questions about this. It's just something that's really cool. It's a passion project for BHIS and active countermeasures for sure. So with that, let's get out of here.
Awesome.
Usually, Shelby, I want to make sure, did I get everything?
Yep, you hit all the checks.
Woo!
Great. Thank you, everybody, for joining us today. Once again, I did want to reiterate, this has been recorded and will be posted to the ACM website along with our YouTube page. You'll also receive a certificate for today through an email tomorrow.
All right.
Thank you, everybody, for your time. We really appreciate it.
Yes, enjoy the rest of your day.
Thank you, everybody.